Hey guys, welcome back to Level 3 of JavaScript Best Practices. This section, the final section of Level 3, is about number nonsense. So in JavaScript, decimals are actually kind of crazy because JavaScript uses binary floating point values to handle all of its decimal-based operations. If we pull up a little console.log here of a simple addition, 0.1 plus 0.2, well that's just 0.3, what? There's a 4. There is a 4. There was no 4. There is a 4 now. I don't know where it came from. Well, I kind of do. It's binary floating point values, right? Which are used primarily for performance because they do enhance performance in a lot of ways, but there's definitely a trade-off between performance and accuracy in this case. Taking a look at a couple other examples, if we did 0.1 plus 0.2 plus 0.3, we get 0.6. Oh. There's a 1 there. There's a 1. There was not a 1. Now there's a 1 in that spot. Crazy. One of the crazy things about binary floating points is that they are not even associative in this case. If I tried to add 0.1 and 0.2 over here in parentheses and then add 0.3, well, I get the same exact thing that I got before without the parentheses. But if I try to add 0.1 to the grouping of 0.2 plus 0.3, magically, I get what I'm expecting, 0.6. Fine, I'll just jump off a bridge, everything will be just fine. Now, floating point arithmetic using binary numbers inside of a computer's arithmetic logical unit, that's slightly outside the scope of JavaScript best practice, wouldn't you agree? So what we're going to do is give you a little bit of resources at the end of the course for you to go research floating point arithmetic because all developers should have a passing familiarity with it. Instead, here in this course, we're going to give you some ways to kind of constrain JavaScript's occasional number nonsense, as well as get consistent results regardless of the internal operations. So first, we'll talk about a few methods that help improve your decimal visualization. First, there is the toFixed method that's going to allow us to select precisely the amount of decimal places we want to display. Over here, you can see we're storing the result of our crazy 0.1 plus 0.2 addition in a variable called number, and then we're going to log out num.toFixed1. That means we want exactly one decimal place to be shown on our number, and we get 0.3, exactly what we would like. Now you can stick any amount of decimal places in there that you prefer. If we pass a 4 in to num after we have created a new addition on 0.1, 0.2, and 0.3, we can see that we get 0.6000 for 4 total fixed decimal places. Important to know about toFixed is that it's going to round to the very last indicated position that you have provided. So if you're dealing, for example, with percentages of money, then toFixed can handle that hundredths rounding for you at any time. Here we've got a function called tax. It's going to take in a price of some object as well as the tax percent that that object is subject to. On the inside, you can see that we return the price times percent divided by 100, which will give you exactly the tax that you need, but we're going to return it to a fixed decimal place of 2. That way it is in money terms with 2 decimal places. You can see here if we called the tax method on $9.85 as well as with a 7.5% tax rate, what happens on the inside is we get $9.85 times 7.5 divided by 100, but that's going to give us 0.73875. Now, our toFixed with 2 in it is going to look at the third place to ensure 2 places will be correctly rounded, and since 8 is greater than 5, the 3 will increase to 4, and we'll get 0.74. But, look, that's a string. What can we do about that? How are we going to use a string numerically if we wanted to do other operations? Because if we had a mailed glove that cost $9.85 as well as some armor tax that was 7.5%, and we wanted to know the total price of this mailed glove in this shop, we would add the mailed glove variable to the results of our tax method, thinking that we would get some number out of the tax method, but what that would actually do, that escalated quickly, would give us 9.850 0.74. What weird. That's because it tried to concatenate a string to a number. Thus, we will need a new method to help use the rounded value in further math operations. A cool method that will help us out with that is called parsefloat. It's going to turn strings that have decimals into numbers to be used. A combination of toFixed and parsefloat will let us use values of exact length in all of our math operations that we might desire. So you can see I've added a parsefloat around my mathematics as well as my toFixed. And what that's going to do is it's going to return an actual decimal value back from the tax function. So now when I pass in 9.85 and 7.5, I'm going to get 0.74 the number, 0.74 the number, instead of 0.74 the string. That makes it very usable in the addition math that I've got doing with mailed glove. So you can see when I log that out, I'm going to get 10.59 in money. And now we're good for display or other usage inside of totals. ParseInt is also a very valuable method that will convert numerical strings. But instead of looking for a floating point number, parseInt is going to seek the very first available integer on the front of any string. So here you can see if I've got parseInt on a string 88, it's going to return a very nice 88 to me. But if I pass in a string that has an integer on the front, parseInt is going to try to help out. It's going to try to provide any integer that begins a string of other characters. That's slightly weird, very often dangerous. Same thing with parsefloat too. If I pass in a sentence here, 3.28084 meters in a foot, parsefloat is going to look for the termination of all of the numbers after any decimal point is encountered. Something to note, if a string does not begin with an acceptable value for either method, however, you'll get that JS value, not a number. More on this in a little bit. One thing we want you to know about parseInt is that it will trim off any decimals it encounters without rounding. So if I were to pass in this string 9.85, I'm going to get 9 back. That may not be what you were expecting if you thought 9.85 should become 10. So watch out for using parseInt in a rounding situation. Now, though parseInt is often super valuable, it can cause some unexpected value errors that we want to make you aware of. That's because parseInt will accept octal, or hexadecimal, or decimal values. Thus, we want to use this with a little bit of caution here. Check this out. Say that we've got a user age variable that takes some data from a user, but that the user, for their age, actually made an error in typing and put in 021 instead of 21. If we use parseInt on user age in modern ECMAScript 5 systems, it's going to give you exactly what you want. It's going to trim that 0 off the front and make it a 21. Pretty cool. But if we use parseInt on user age and we're in an older system, it may think that you are trying to pass an octal value, which is base 8, and it's going to try to help you out with a conversion back to the decimal value, and it's going to give you a 17. Now, if this was a dude registering on a cruise ship and he put in 21, but the system thinks he's 17, he's going to have a uniquely different experience there. Now, this situation very much points to the idea of progressive enhancement in internet technology, which means we need to keep all of our users' possible errors in mind at all times. When dealing with our string to number conversions, it's going to be very prudent, very helpful, cautious, to make sure that we pass in a defining radix value. The radix value is going to tell parseInt exactly which base in which you want your value to be treated. So here you can see we've got a parseInt method on that 021 string, but now we're going to pass in 10. And that's going to say, yo, I want this to be a decimal value, whatever you get out of it. So parseInt's going to take that radix value, look at it, say, okay, decimal value, got it, and send it back, and we get 21. Always do this when you cannot be assured of a browser version or a user's input. In other words, forever. Another cautionary tale we want to tell here in this section is that of testing for number presence before you try to do an operation with that number. Now, using not a number to check if values actually exist, that seems like a good idea. Not a number, if I can use not a number, that should work, right? Usually it tries to kill you. Take a look at this. If I do type of not a number, that's a number. The type of not a number is a number. So, okay, so if I got console.log not a number triple equals not a number, I'm trying to see if not a number is in fact not a number. And guess what? That's false. Not a number is not a number is not a number. Something, right? Crazy. And then if I use the is not a number method, which a lot of people turn to, on the string 42, that's false because this is a string. This is a string and it's not a number. It's not a number because it's a string. I don't know. Yeah, it's kind of crazy in the number environment, especially with not a number. And it turns out this is not a number method is actually looking strictly for the value, not a number itself. Fun. What we want to give you here in terms of best practice is please, for your own sake, do a double check to avoid insanity. If you're unsure about the data type, but you're very highly reliant on the fact that it is a number, you got to use type of and is not a number as a best practice. Let's check that out. So if I build over here a function that says, is this actually a number, don't lie, and I pass in some data, right? What it's going to do is it's going to return the Boolean result of this compound conditional in here. First thing it does is it checks to see if the type of data is in fact a JavaScript number value, right? Not only does that have to be true, but we also have to make sure that the data is not in fact not a number, the value, NaN, right? Because look up at the top, type of not a number, that's a number. So if I just check to see if the data is a number, I could be screwed if my value is actually NaN, right? So we want to do both of those checks to actually make sure that we have the number that we're looking for. Checking that out over here, if I call, is this actually a number, don't lie, on 640, I get it true because cool, that's a number and it's also not NaN, right? If I call that method on the string 640, well, the first part of my condition, my compound conditional, breaks because type of data is not in fact a number, and so I get false. And now here's where the money is. This is where you have avoided getting any wrong answers back. Is this actually a number, don't lie, on not a number? That's going to be false because the second part of our compound conditional will not be correct. Now, if you want a little leniency, especially for form data, which we know can come back crazy all the time, then you want to use parse methods. If numerical data may show up sometime as a string, then you want to parse your data before you do your check and also add additional checks. So let's check it out. We're going to build a function here called checkValidZip. We're going to check on a valid zip code in some field. First, we'll actually get the entered zip code from the value of the zip ID element. Next, we will try to parse int on that entry and pass it to the user zip variable. Then we'll get a try catch block going. Oh, we're back to those, huh? If is this actually a number, don't lie, on user zip, meaning we do actually have a number here, then what we're going to do is check to make sure the length of that zip code is only 5. So we've taken the user zip, we've fixed it to a 0 decimal length, and if that length happens to be 5 of that number, then we will actually get the number 5 out, and we will return true. Our valid zip is cool. Otherwise, we're going to throw an error that says, nope, it ain't good. And then, in that second else block, we're going to throw an error if our is this actually a number, don't lie method found out that our user zip was not in fact a number. And then in our catch block, we'll just handle the error gracefully, telling the user to please enter a valid zip dude and return false from checkValidZip. We could put a bunch of other error responses there as well. So now over here, if we got a zip code field and we enter 32803, then we get a true value back because we have a length 5 on our zip code and it's actually a number. But if when we were entering that zip code we hit 3280 and our finger was actually hitting the shift key and we put 3 down and it gave us a number and we entered that, we would get a false back from our checkValidZip because we do not have an actual number going on. Yeah. So that is the end of the nonsense of numbers and also the end of the Crystal of Caution. We will give you some challenges on crazy number stuff, and we'll see you back in the next level. Just kill me now. T-shirt objects or something nuts. Why would there be t-shirt objects in the armory? ID or